This is example 8-8, a bridge pier model. So we can see we have this pier here that's holding up a bridge, and we're interested in the flow around this bridge pier. And we're supposed to build a model with a 1/15th scale. That's anything that's 15 meters in my bridge is going to be 1 meter in my model. We know the river is going to be flowing with 0.8 meters per second, and we're supposed to find out what the flow velocity in the model should be to get the same flow behavior. In this case, we're interested in the flow around the pier, so that means we're mainly going to be interested in viscosity forces and viscous forces, so we know we'll need the Reynolds number. Reynolds number, we know RE is equal to rho times V times L divided by mu. And our prototype and our model have to be the same, so we can say RE model is equal to RE prototype. That means now density times velocity times length over mu, all of that for our model, equal to rho times V times L over mu for our prototype. Now if we write these out, then what do we get? Well, we will get the density. Well, the density is going to stay the same because it's water at the same temperature, right? So we can say, we'll just leave it as rho. Then we'll have the velocity in the model, which we're trying to find. Then we have the length in the model. And then mu is going to be the same for both cases because the temperature doesn't change. Is equal to rho times Vp times Lp divided by mu. All right, based on that, we already know we can cancel out the rhos and the mu's. All right, so that means we get Vm times Lm is equal to Vp times Lp. And of course, let's go to the next page here, right? That means if we want to have the velocity of our model, Vm is then going to be Lp over Lm times Vp. Now we know that the model is 1/15th of the actual bridge pier, right? So we can say Lp divided by 1/15th times Lp times Vp. That would mean the 15 jumps up, the Lp's cancel, 15 times Vp, so that'd be 15 times 0.8 meters per second. That means the velocity in our model would have to be 12 meters per second. Right, so if I wanted to study how the flow is occurring around this bridge pier with a model that's 1/15th the size of the overall model, then my velocity would have to be 12 meters per second.